Homework sheet U9, question 2. In A part 1, we're asked to differentiate x to the half log 3x with respect to x. Now when I do differentiation problems, I don't like them starting without any kind of letter equals beforehand, so I've called mine y equals, though this is optional. This is a question for the product rule, so I've split up my parts into u equals x to the half and v equals log 3x. I need to find du dx, which is half x to the minus half, and I also need to find dv dx, but this is a chain rule problem. So I'm going to make the substitution 3x equals w to get v equals log w, and then dv dw is just 1 over w. And if v is equal to 3x, that means that dw dx is equal to 3. So dv dx is 3 times 1 over w, which is 1 over 3x, which is just 1 over x. I'm just going to box up my u, v, du dx and dv dx terms, because these are the ones I want to use for the product rule. To find dy dx, I need v du dx, so that is half x to the minus half times log 3x. And I add that to u dv dx, which is x to the half times 1 over x. And I can simplify this to get half x to the minus half log 3x plus x to the minus half. In part 2, we need to differentiate y equals 1 minus 10x over 2x minus 1 to the power 5. Again, I've added a y equals because I don't like differentiation questions starting without anything at the beginning. This is a problem for the quotient rule, so I've separated up my numerator as u, 1 minus 10x, and my denominator as v. I need to differentiate each of these terms. du dx differentiates to minus 10. dv dx needs to use the chain rule. I could, as before, come up with a third letter w to make the substitution, but as this one's a bit easier, I'm going to do it without. I get 5 lots of my bracket to the power 4, times by the differential of the bracket, which is just 2, to give me 10 lots of 2x minus 1 to the power 4. When I do my quotient rule, dy dx is v du dx minus u dv dx all over v squared. So if I substitute these terms in, I get 2x minus 1 to the power of 5 times by negative 10 minus 1 minus 10x times by 10 times 2x minus 1 to the power 4, and that's all over 2x minus 1 to the power 5 squared. Now I want to start simplifying this, and I want to take out common factors. So I can see that I've got a 10 on the top in both terms, and I've got a 2x minus 1 to the power 4 on the top in both terms. So I'm going to take those out as common factors. 10 lots of 2x minus 1 to the power 4. That leaves me with minus 2x minus 1, so I'm going to take that minus and make it 1 minus 2x. And then I have to take away 1 minus 10x. I can also simplify my denominator to get 2x minus 1 to the power of 10. Now if I've got 2x minus 1 to the power of 4 on top and a 2x minus 1 to the power of 10 on the bottom, I can simplify my denominator to get 2x minus 1 to the power of 6. And I can also simplify my numerator on top. 1 take away 1 is 0, and minus 2x minus minus 10x is 8x. So I can finish off with 80x over 2x minus 1 to the power of 6. In part B, we've been asked to find dy dx. We're given that x is equal to 3 tan 2y. I'm going to start by finding dx dy by differentiating this expression with respect to y. Now, tan y differentiates to sec squared y, so tan 2y is going to differentiate to sec squared 2y times 2 using the chain rule. The differential of 2y just gives me the 2 there. So this gives me 6 sec squared 2y. Now, I'm not going to want to give a final answer in terms of y. I've been asked to give my final answer in terms of x, so I need to make my substitution. Now, x is in terms of tan, and I've got an expression in terms of sec, so I'm going to need to use a trig identity to write one in terms of the other. I'm going to start off with the fact that sec squared x is equal to 1 plus tan squared x, so sec squared 2y is equal to 1 plus tan squared 2y. With a bit of rearrangement of my top part here, x over 3 is equal to tan 2y, so tan squared 2y is equal to x squared over 3. And this gives me sec squared 2y is equal to 1 plus x squared over 3 squared, or x over 3 all squared. If I substitute that back into my expression for dx dy is equal to 6 lots of 1 plus x squared over 9. So if I times everything up by, if I expand my bracket to start with, I get 6 plus 6x squared over 9, which is 2x squared over 3. And because I'm going to want to flip this fraction upside down to find dy dx, it's much more useful to have a single fraction. So I'm going to write this as 18 plus 2x squared all over 3. Finally, to find dy dx, I can just flip this one single fraction upside down to get 3 over 18 plus 2x squared.